um, which, like if you combine equation 1 and equation 2, if you eliminate x, you're just left with a y and a z, and that pairs pretty good with the last one here. If you combine equations 1 and 3, you can get rid of the z, leaving you an x and a y to go with the second one here. So the reality is it doesn't matter which way you go. Do you remember this at all from class, or anything from class kind of stand out to you at this point about what to do?
I mean, yeah, like the two things like she taught us how to do is like elimination and substitution, but I like don't really get it. I just get like the concept.
Okay, so and that's kind of where we're going here. Like in equation 1, let me write equation 1. Equation 1, you can solve for x. X equals 3z because you would add 3z to both sides. Does that make sense?
Yeah.
Now, if we put that into equation 2 is 5x minus y equals 0. If we put this into equation 2, 5 times 3z minus y equals 0, you get y, or 15z minus y equals 0.
Mm-hmm.
Is that okay so far?
Yeah. No, yeah, yeah.
Okay. And then what you can do from there is you can solve this for y, 15z equals y. And if you go to that third equation, which is 3y minus z equals 0, you can put this in for you can put all of this in for y here. So it becomes 3 times 15z minus z equals 0. And so notice there's only one variable.
Yeah.
So you're kind of like, it's like a waterfall. You go down to the next one and the next one, and then you maybe have it here. So this ends up being 44z equals 0. When you divide both sides by 44, you get z equals 0. And that's an important start. It's not a problem.
All right. So you just like plug the zero back into the other ones?
Yeah, and you can start with like the last equation there, 3y minus z equals 0. You end up getting that when you put 0 in for z, you get 3y equals 0, and y ends up equaling 0.
Yeah. So would X also be zero?
Yes, all three of them are 0 in this problem.
Huh.
Please check that before we proceed.
All right. No, yeah, it says like good job. So
Okay. All right, so the next one here is it's not as easy to solve for a variable
yeah.
because they're just not as nice. Like and that's where you have to use this elimination technique. Um, so for example, like 3 goes into 6. That's kind of a good thing. Um,
Mm.
the 3x down here goes into the 6x. The negative 2y and 2y are opposite in sign. You're kind of looking for some things that stand out. The thing which I'll suggest here is to combine equation 2 and equation 3. So if you just add those two equations together, you get 8x plus 3z equals negative 52.
Okay.
Is that okay how we did that?
Yeah.
And the first equation has an x and a z in it, so we're in good shape because we want to match up the variables.
Mm-hmm.
So this is where you would use elimination. And you can eliminate either variable, but because the z is already opposite in sign, that's what you're kind of looking for when you decide which variable to eliminate.
All right.
So we're going to multiply the top equation. Let me switch colors here. Top equation by 3. Sorry, by 8. Sorry, so it's the other coefficient.
Yeah. No, yeah.
And then the other one would be 3, be the other coefficient. The numbers get kind of large. I mean, there's not really much you can do about that. If they get too large, you should say, maybe I've done it wrong. No guarantee of that. But what you're looking for is that, okay, everything cancels. So this becomes the z's cancel, but you have 82x equals negative 410. When you divide by 82, believe it or not, x equals minus 5, like that.
All right. Wait, hold on. Where did the 18 come from?
You're multiplying everything by the 3,
Okay, yeah, I see.
everything, everything
All
by
right.
the 8.
All right.
So now that you have x, you can go to the top equation to find z or the bottom equation to find y. Like either one is good at this point. Like 6 times negative 5 minus 8z equals 2.
Mm-hmm. Um,
Negative 30. And then you can similarly use the x value in that last equation. 3 times minus 5 plus 2y equals minus 89. And then you get 2y equals minus 74, y equals minus 37. So your final answer is minus 5, minus 37, minus 4.
all right.
Please check that and let me know if there's any questions.
Oh, okay. Yeah.
Always a good
Right.
idea.
It's right.
Okay. All right. So do you want us to do one more of these, the last system, or move on to something else?
Maybe can we just do the last one just to be sure?
Sure. The reason I'm asking is because with the shorter lessons, sometimes it can get away from us in terms of getting, everything done that we want.
Yeah.
So when I look at these first two problems here, I see that equations 2 and 3 are opposite in sign here. So if you were to combine those, it would get rid of the x. So there would be 5y plus 5z equals 5, like that.
All right.
So that's pretty good. But we really need to get rid of x in the top equation as well. So if we kind of just reset here, and it's a little easier because I've got the copy and paste here. But if we look at like how can we get rid of the 3x, that minus x is really appealing, because if you multiply everything by 3, you get minus 3x plus 3y plus 6z equals 9. And if I just rewrite the other equation above it, if you add these together, do you see that the x's now go away completely?
Yeah.
All right, so it ends up being 15y plus 7z equals 23. And then you bring this other equation down with it. 5y plus 5z equals 5, like that.
Mm-hmm.
Okay. Now, which variable do you want to eliminate? Do you want to eliminate y or z?
Why?
Y, because 5 goes into 15. So you're going to multiply everything on the bottom by negative 3. So it ends up being negative. Let me grab the right color. Negative 15y plus 15z equals 15. 15y plus 7z equals 23. Add them up vertically, and you end up getting did I do this right? Okay,
Um,
22z equals 38.
mhm.
That doesn't look very good. Might miss something here. 9,
I don't know. It looks
3x total
like
y.
some of them do have like weird like fraction answers. Like it's not like out of the question.
Okay. Let me just quickly solve this on my own calculator to make sure that we're equal. Because if this is wrong, it ends up propagating through the whole rest of the problem,
No,
which
yeah,
we
of
don't want. And just need a
yeah,
short amount of time to do that.
of course.
You might even be hearing me smash the keyboard here. All right, there we go. All right, there's that. Yeah, so I made a mistake there. This one does work out nicely.
Oh,
Oh, there it is. Negative, it should be negative 15. Negative 15. Okay. And so this
oh,
ends up being negative 8, z equals 8, z equals -1.
yeah.
Okay.
That
Okay.
makes much
So
more sense.
that so if I can make a mistake, and I do this all the time, like it's very easy for a student to make mistakes. You're always, check, check, check,
Mhm.
check if you can. All right. That means we can find y or z. I'm going to go to the second equation, the 5y plus 5z equals 5. 5y plus 5 times -1 equals 5. You end up getting 5y equal 10 or y equals 2. And then you have your choice of equations to go back to. You want to choose the cleanest one, the one that's maybe easiest to solve for that missing variable, which is the first one there. I'm sorry, the third one there. So the x value there is what we're trying to find. We have x plus 4 times 2 plus 3 times -1 equals 2. So it ends up that x is -3. Why does that not look right? No, it is right. Okay. So we got -3, comma 2, comma -1.
All right. Yeah, it was right.
Okay. All right. I know there's several more here. Do you want me to just do them in the order they came in on the email, which is the next one is question 9, the how many quarts?
Yeah, no, yeah.
All right. So these are called mixture problems.
Yeah, I like have been trying to do these for like a few days by myself, and I like haven't been able to.
So there's kind of a recipe for them. There's always what's called a total equation, which is x plus y equals the total. So in this case, uh, butter, fat, milk, butter, fat, milk, 4% versus 1%. That's the total. Then
Mm,
there's like a percentage equation, which is percent times amount plus percent times amount equals percent times amount. It's always the same in these mixture problems.
all
So
right.
the percent is literally a percent. So 0.04 x plus 0.01 y, I'm getting those numbers from right there, equals, we want a 2% of the total amount, which is
60?
60. Yeah.
Are we gonna like draw a chart or
No.
like do we not need it?
Why would we do that? We're basically done. I know they
Oh,
do the
okay.
charts. I know they do the charts in the school, right? But we don't
Yeah.
need to do that. That
Okay.
you can if you want. I'm not opposed to that, but I'm not going to.
All right, because this is like way easier than like trying to do that.
Right. So you're down to like a system of equations again. You can use one thing you might do here, and no calculator on these as well.
No. Or
Oh, you're
sometimes it like depends.
I would
Like,
assume you'd have a calculator here on this one, but you might multiply everything by 100 on the second one to just get more comfortable numbers. That would be a
oh
normal thing
yeah.
to do here. So that would be 4x plus 1y equals 120. And
Mm.
then the other equation is x plus y equals 60. So you could use substitution. You can also just straight subtract the equation, which I
Oh,
really like. I really like if you're comfortable with it. You're subtracting each one. It's like 4x minus x, 1y minus y, 120 minus 60.
oh, I didn't know you could do that.
It is in the playbook here of it. So this ends up being x equals 20. And that's you got to make sure you know like which one's x. X is the butterfat milk 4%. It's that because I made it X. Like
Um,
if you just got to make sure you know what you're actually doing here. So that's 20. Part B is probably asking you how much of the 1%. Since it's 60 total, you know that part B is probably 40.
all right. Wow, this is like so much easier than the way like she said to do it in class.
Yes. There is another kind of one of these problems down at the end, which is the motorcyclist problem. It's not a
Yeah.
mixture problem, but that would be kind of the next logical one to do. Or we can go to the graphing.
No, you can go to the motorcycle one. Like it's like chronologically next, I think. So it's
Oh yeah.
like,
Okay.
and this is another one like I got wrong on a quiz. So, you know.
Well, keep doing the best you can. Two motorcyclists start at the same point, traveling in opposite directions. So a picture here is somewhat helpful. They're each going that direction. One travels 4 miles per hour faster than the other. In 8 hours, they are 304 miles per hour. So the overarching equation is distance equals rate times time. Are you driving right now? Are you a driver on the road?
Not yet.
Not yet. Okay. This equation will make more sense once you start driving, but it is the equation here. So you have to do a D equals RT for each of these. Okay. So one travels 4 miles per hour faster than the other. So who's going faster, the one on the right or the one on the left? You pick.
Oh, the left, I guess.
So the left guy's going faster. So we're going to call the ones on the person on the right's rate is R. The one on the left here is going to be R plus 4.
All right.
Like we don't know what it is yet, but if they're going 50, they're going 54. Is that okay?
Yeah.
Okay. In 8 hours. So how long is the guy on the or girl on the left riding? How many hours?
8 hours.
How about the one on the right?
8 hours.
Okay, very good. So the one on the left here, we're going to call them D1. D1 is R plus 4 times 8. The one on the right, D2, is R times 8.
All right. Do they have to be equal to like
Not
three,
yet.
four,
Yeah,
four?
yes, the two distances are yes. So D1 plus D2. So what you do is you kind of work on the scenarios separately, and then something combines them together. The two distances together are 304.
Mm.
So you write R plus 4 times 8 plus 8R equals 304. Notice you're down to one single variable, which is very
Mhm.
nice. Okay, we're going to distribute that 8 into both. So that's 8R plus 32 plus 8R equals 304. And then you combine like terms. Subtract 32. 16R equals 272, which doesn't look like it divides into 16, but it probably does. It does. R equals 17. And be really careful. Like R is the rate of this person, the slower one. You got to go back and be like, which one are they asking for? And maybe they're asking for both because it's a two-parter. But the slower one is the R. The
All right.
faster one is R plus,
4.
yeah, that's probably part B.
Yeah. So 17. So 21 for the faster one.
Yes.
Nice. All right. It was correct.
On to, I guess it's 17 maybe. I don't know. Let me see which chronological order. 15,
I didn't really
11.
send them like in an order. Like it's fine, like whichever one we do.
Well, they do a decent job of putting these in the right order. I'm going to
Um,
start with 12. And we will run out of time here, but if you want to go to Desmos and graph these, you can to get like the final answers.
all
Whatever,
right.
sure.
Yeah, like some of these are like really similar. So like it's okay if we like jump around, you know?
Okay. So first one here, graph the solution to systems of inequalities. Now for the first equation here, y equals x plus 4, I'm just changing it to equals. What's the slope and what's the b value?
The slope is 1 and the b is 4.
So you start at 4, the b value, and you do the slope of 1. Now, is it a solid or a dashed line? And it's based on that symbol there.
Uh, I don't know. I was absent when we learned this, so like I'm kind of in the
So
dark.
that when there's a line underneath, that's a solid. If
All
it's these
right.
two, it's a dashed.
Okay,
So this
okay.
so this is a solid line here. And then only when it's solved for y, only when it's solved for y. If it's y less than or y less than or equal to, you shade below.
All right.
Y greater than or y greater than or equal to, you shade above. So this one is going to be shaded above. So I'm going to put little arrows here for the moment, so that we know it's going to shade that side. All right, now on to the second one here. If we rewrite it, it's y greater than or equal to minus x plus 5. What is the slope and what is the b value of that one?
-1 and 5.
Yes. So go to 5, and then we're going to go down one, right one. So go down to the right. It's also solid line. And then this time it's great. It's above. So above is that direction. And you're looking for the overlap. So you'll get that little paint fill tool and you'll shade in this region up here.
Wait, only in that one, like not in the other part?
It's got to be both.
Oh, all right.
Both. Why don't you pick the last one we do?
Okay. Sorry, my iPad's being slow.
I got either 17, 15, or 14 on my screen.
Let's just do 17.
Okay.
My iPad's like lagging. I don't know what's wrong with it. Hold on. Okay, yeah. Like that one,
Okay.
like I tried to do it and I got it wrong.
All right, so this one we're going to solve for y. So you end up getting y greater than or equal to minus 2x plus 8. If you can, if it's not too bad, solve it for y. Because then it's just like the last ones. The slope is -2, the b value is 8. You go up to 8, down to right one, down to right one, and so on. It's a solid line again. Now, because it's y greater than, you're going to shade above. All right. X less than or equal to 6. That is a vertical line at 6. If there's 6, it's a vertical line. And you're shading to the left of it. Less than means to the left. So you can actually kind of see what the region is looking like. It's over here for now.
Uh-huh. Wait, why is
The
it not
line,
at the bottom?
I'm sorry, what?
Like, you know how like it has like the triangle like up here and then like down here, like lower,
Yeah,
like there. Like, why don't we shade that in?
because it's to the left and to the right. There's only, whenever you have two lines, there's only one correct region out of the four. But we're
Uh,
not we're not done. There's more to do here. This
alright.
greater than 0, x greater than 0, that's at 0 here. So
Mm-hmm.
you have to draw that line in, and it's to the right of it. And then y greater than 0, I'm running out of colors here. I guess we can go green. That's here. And then you're shading above it. So it's a little bit, let's see if I can do it in gray here. Maybe that'll, it ends up being this region in here. Kind of a trapezoid. Why didn't it do that? That's bad. Got it. I'll do it in highlighter.
All right. I got it.
All right. The other ones are very similar. Should be able to tackle those on your own. So we're out of time here for today. I hope this helped.